your relative permeability is going down. And I've had that happen. So watch the conditions around these things. These aren't all the same. There will be parts of the shale that will have low saturation, parts of the shale that have high saturation. Now your shales are mostly undersaturated. That's why you lose a lot of your water volume when you frack. In the Barnett, you'll get back 50%. Marcellus, about 50%. Go over to Haynesville, you might get back 5% of the water you put in there. And the shale is just going to absorb the rest of it. It'll just say, thank you very much, hold on to it. Permeability may go down, may go up. What I can tell you is if I see a well like that doesn't return a large amount of fluid back from there, I start looking not only at the water saturation, but the mineralogy. Because something in there is absorbing a lot of water, and clays generally are the one that absorbs the most water. That may be a case where maybe I better use a KCl or a clay control additive, because most of the time I don't. Never used one on the Barnett. Never used one on the Horn River. Didn't have any problems with them. But the Horn River, I mean the Barnett was so forgiving, you could flow that thing back. You know, you push the frac in just as soon as the trucks were off the pad and the well was hooked up, you were flowing that thing back into a tank fast as it would go. You couldn't hurt those wells. In the Eagle Ford, for example, though, if you bring those wells back too fast, sometimes you can hurt them. Different parts of the field, different responses, but you can hurt those wells. So you might start out with an 8/64 and work your way up with a maximum pressure drop of 25 PSI per day. Those aren't my numbers. That came from an engineer that worked that out. That may be what you need on this one. And it may be that a frac hit after that, all of a sudden this thing is frac hit. Well, do I put it on production and just draw it down again? Or do I take it slow again? I don't know. It's just, these are the things that interest me on this deal because we know so little about it. And this is actually the data from this, and like I say, there are 3,100 wells in here: Bakken, Eagle Ford, Haynesville, Woodford, and Niobrara. The Niobrara, I will say this, the devil lives in the Niobrara. You can frack it, and if you don't hit the natural fracture system, I have never seen anybody yet make a well out of it unless they hit it initially. It's a tough reservoir to work in. Okay, but look here at the positive hit total. 50% in the Bakken, 24 in the Eagle Ford. Haynesville is 58. Woodford is 4. Positive hit. I mean, you hit the Woodford, it's going to kill your well. And then, but no better in the Niobrara, but the Barnett was the most forgiving. Man, these are just my estimates from a lot of wells that I've read about there. About 50% of the time it helps you. So there are basins and shales that you're not going to do nearly as well in if you get a frac hit. All right, and now some maps here, and there again, this is just that Eagle Ford. The green are the positive hits, the red are the negative hits. There's a little bit of movement around here as it gets into the less gas power. And this is a heavier oil up in here. It's about a 20 gravity. Down into here, you're starting to get into the extremely hot gas. But up here, where the oil lens is best, you're seeing about a 50-50 deal in that particular part of it. So it can vary. It's all bad down here. It's a lot of good up here from a frac hit. Learn your fields. This is what we have to do. Bakken, very good field for frac hits. I mean, it positively helped you in a lot of those cases. But when you got to the Woodford, it's hard to see any green in there. You just damage the heck out of those things. And then the Cana Woodford, which would be up a little bit north of here, it can be even worse. So findings, positive and negative hits, are sometimes correlatable to specific shales and specific areas. Don't just take it for granted that it's either going to be potentially good or potentially bad. Pull some information down and go looking at those things. Now, how about simple ways to protect a well against a frac hit? Well, first off, we didn't do anything and it damaged the well. Then we shut the well in, didn't always help. Then we loaded the well with fluid, and then we loaded the well with liquid and put a gas cap over it, and we let some of them just flow. None of those things are 100% protection. In fact, you'd struggle to find them that you weren't finding a lot of frac hits that created either damage or a production loss. But the one thing that has worked almost every time that people have done it is if I'm going to frac the child well over here, the second well that came in, do a small refrac on the parent well, the first well that was there, just do those simultaneously. And that's been the best way to protect these wells. So there's still some argument around in there. There isn't one thing I've said that's 100% accurate for everywhere. You can get some pretty good response on a refracture treatment, but I've seen a lot of refracs fall flat on their face. My luck with refracs is not all that fantastic. So I'm a little bit careful after that. Now, recovery after a frac hit, we got a couple choices. We got chemicals, solvents, surfactants, acid, and the volumes that we deal with. We might even use some methane gas to push it down. I don't know, I haven't used that yet. But focus on load water recovery, which is more popular in conventional wells, or look at the reason for the production loss. It might be a near field shallow one in that case you can treat it. But if you can work out by pressure transient analysis that damage is deep in the reservoir, and I haven't seen too many pressure transient effects on shale, but I have seen some interferences. If you can work out where that is, it gives you an idea that maybe a chemical unit won't work because of the area to volume ratio and the amount of fluid required. And by the way, if you're going to use production chemicals in these wells, what we found is you need about 1.5% to 2% by volume in the treating fluid that you're pushing into that well. Not the whole thing, but the treating fluid. Don't try to save money and go to 0.1%. You might as well leave the chemical out entirely. That's what the technology is actually seeing. Now there's other things that you can get into. Let me turn that arrow off here. All right, then the history here, the frac hits are more common in areas where it's closely spaced. We've pretty well worked through that. But what's going on? Is it closure of the fracture? Is it loss of proppant? Is it a deposit that's made? Is it an emulsion, a sludge? Something getting in the way? Is it clay swelling? Is it water retention? If you work that out and get a pretty good idea of what's happening, the odds of you doing a failed treatment go down significantly. So it's a factor of economics. We've got to figure out why it's being produced. Leave the mechanical stuff out of it, leave the damage from the frac hit mechanically, leave that out of it for a bit here. Try to figure out why it's coming in and what that damage is and where that damage is, because that helps you a lot. There's a lot of pretty good information here about close spacing, planar fracs, simultaneous or sequential fracs. Simultaneous and sequential work extremely well in the Barnett and the Woodford, but in most ductile formations, they don't work all that well. That's what we're seeing from the producing zones that we're in. So these again are some areas to take a look at here that would give you pretty good information. So in close, what I could say is go back. I'm kind of beating this thing to death. Separate your damage, mechanical, from your production loss. Take your production loss. Why? And you actually may have to use some chemistry, catch some water samples. There is an SPE paper out there called Message in a Bottle. It's by a guy from Nexen, and they worked out a beautiful method here of figuring out where that water has been. And by using the salt content and ion pairs, sodium, magnesium, calcium, strontium, whatever they were using, and you pick some of those up from just mixing with waters, but the others you have to pick up from actual leaching, which you get back into the natural fractures themselves. and they could come up with a pretty good idea of whether you were in a planar frac or whether you were in a complex or network type fracturing. So these are just some thoughts out there. Questions? Ideas here? Did I put you all to sleep? Yes?
Just some clarification on frac hit.
Uh-huh.
Are you talking like a fracture reaching another wellbore, or seeing fluid in another wellbore, or?
Okay, now I should have defined that right off the bat. If you have fractures reaching out and you overlap, and that if both wells are yours, and the wells are my thumbs here, if both of those wells are yours, this is really good to have maybe a 2 to 3% overlap of the frac tips. That's simply because you're going to leave less unprocessed reserves behind. However, that isn't what gives you damage. That might give you a little bit of a pressure rise, but the pressure has to be transmitted through the fractures. That would be a beautifully designed job if you could just touch frac tip to frac tip. What I'm talking about is if I have 2 horizontal wells and I frac from where my cheap watch is over to where my elbow is, I don't want to put a perf cluster over here. I want to put it down here where that frac isn't going to go through it from either end, because that's the one, wellbore to wellbore connection with a fracture, that's the one where you get a lot of damage, particularly if you're pumping at high rate. You want to kind of damp down the fracture hits, you reduce your rate a little bit. The only issue there is you don't get quite as good a well. Okay. Yes, sir.
So when you have a frac hit between 2 wells, and you say that with production and depletion, the fractures tend to close, right? Wouldn't you have less of an effect to the frac hit as you produce from both wells? Because then connection will go.
And if you look at the interference testing or the connectivity tests that you can run, and the one I'll take, and I think it's in Message in a Bottle. They had 3 layers that they were fracturing. They had the EV, the Otter Park, and the Musquash. And the EV was on the bottom. And they did pressure analysis and found out that there was connection all up and down these things initially. After 30 days, 3 or 4 of those connections had dropped off. After 6 months, there was a very few connections in there. So yes, the formation fractures close. The issue around that, though, is that's flush production. We understand that, and if it was just that, the production should come back up, and in a couple of cases it does. But in a few cases, we've produced these wells for quite a while, and the production never comes back to normal. So it isn't quite explained from what's going on, and we're still going to have to come up with some transient analysis or something like that that's going to help us figure it out. Okay?
George,
Yeah.
you had mentioned some protection practices along the lines of forming a refrac or maybe a defensive refrac offset to a new infill system. The timing of that, I would think, is pretty important. Have you seen anything where people have done simultaneous treatments where they've got like a spread rigged up on that deep frac parent well while they're fracking the new infill system?
I've seen actual ones in
George?
sequential fracs.
I don't mean to interrupt, but for the ones watching, I just got a text, they can't hear the questions, but if
Okay,
you
I'll repeat 'em.
repeat the question, then we're all good. So,
Okay, repeat your question here.
Yeah, so around the refrac and the new infill, fracturing of the new infill system, and how close those 2 systems are to one another.
Okay,
The
and-
timing of when both of those systems are treated.
Comes back to the timing of if I have a parent well and a child well, and if I'm fracking, and one of the best ways that we've seen so far, we don't have a lot of data on it, was to frack both wells. And the way I've seen it is it's a sequential frac. They use the same spread of equipment. They'll frac a small frac in the parent well, and then a bigger frac in the child well, and just work their way back down. And this keeps that area, and you have to be cognitive of, it's not just the distance there, it's where the fractures, it's the fracture plane and where it crosses the other wellbore. But yeah, that's what they're trying to do in that particular case. Yes, sir.
So George, have you seen a correlation between like fluid systems and the chemistry? It was not like, you know, the two ones cross slick water in terms of
Okay.
frac hit percentage on parent
Yeah.
recovery.
Okay, and the question there is, does frac fluid make a difference in terms of the amount of frac hits? We see more planar frac hits than that are damaging both to machine or to equipment and to production. Those are generally either, if it's slick water in a very highly stressed environment where you've just got one fracture direction. Most of the time though, it will be with a gel, cross-link gel, something of that nature. And there's not a lot of data out there on that because most of the fracturing has been slick water, but there's some hybrid systems that are coming in. I think not only is that an issue, and I can't answer your question exactly. I think the proppant and the amount of proppant we put in there that holds that thing open and stresses that area, I think that that's going to be a factor as well. And I realize I'm throwing a lot of factors out there, but this seems to be a pretty complex analysis. Right now, we've seen a lot of fractures with every one of them. We don't see as many frac hits when you have complex fracturing, that is the one where we use slick water on to try to achieve that. Okay? Yes?
So going back to timing, if I'm not going to be doing a protective refrac, is there an optimal time that the parent well has been online before I come in and frac the child well?
I don't know the answer to that one, but I can go to what I've read on refracs. And refracs, it's a mixed bag in terms of whether it's successful or not. The more engineering you put into it, the more knowledge you have, the better your refrac's going to be. But what they're seeing though is if I could refrac, the ideal time to refrac a well, let me put the refrac out there and then I'll try to translate it into a frac hit. The optimum time to refrac a well is within 18 months to about 2 years from the start of production. That's where you still have the pressure and you still have reserves and it has a better chance of being economic. Baker brought out a very good study of that about 2 years ago at the Hydraulic Fracturing Forum. And this was a quite large study. Well, nothing, it's 30 wells or so. But they did see a correlation there between the timing on that. If you waited too long, the pressure was low, it didn't do you any good. I have a feeling on the frac hits and trying to treat frac hits that if you take a frac hit and it never comes back and you sit there for about 2 or 3 years, that is going to be a poor candidate to retreat. I have just a little bit of information on that, but not a lot. Okay? Question?
George?
So you talked about staggering the perforations. You got 2 wells side by side,
Right.
staggering the perforations. Is that only really help if you have highly planar fractures, or if you've got, it seems to me to be a really complex fracture system, and you still find a way to hit another well?
You're exactly right. The question is, if I stagger my perfs, why do I do that if I have complex fracturing and there's no reason to do it that I can see? There's a great reason to do it if you have just these long planar fractures, because if I frac from here and it hits this wellbore here, but the nearest frac is 50 feet on each side, then it will go on, but that won't hurt your well. Now, I say that, and there have been a couple of cases where they have collapsed casing in other wells when they were at really high pressures. And that's happened in the Eagle Ford. Okay? Yeah, you get nodding your head back over there. Yep, there's been several collapses. All right, guys, that's it. Thank you. Oh, one more question.
What do you think about pressuring up the parent well, say with methane?
Well, they pressured them up with water, they pressured them up with nitrogen. I don't know anybody that's pressured them up with methane. But they've actually put water and then nitrogen caps on the top of it. And it works some of the time, but it didn't work all the time. So anything you can do to repressure that well is going to help you a little bit. but I don't know of anything that is a high probability of success in stopping mechanical damage without putting a frac in there. And maybe you have to pressure up and pump a little bit on, maybe you don't frac, you just pressure up and pump into it and hold that pressure. But I haven't seen that done. I haven't seen it. Oh, one more? Okay.
We recently just fractured 8 wells, spread in parent wells, pin wells on either side. One was completed 6 months ago, one was completed 3 or 4 years ago with a sleeve system in it, which doesn't work, but we won't go there. We pressured them up because there really is no other alternative. I mean, what else can you do? Pump, run a packer system. We
Right.
loaded them up. But we don't seem to have any adverse effect. To make a mistake.
Okay, and the statement was, you pressure up a well, you don't know what's happened, no adverse effects. But that's the issue about, did you look at these wells to see which one was the most likely to be fractured into?
We moved water miles east-west.
Okay. All right, so you got a regional fracture system in there somewhere.
Thousands of feet.
Yeah.
west of the well.
Yeah, okay. Sounds like to me that you got a regional fracture in there that is dominating everything you do. And it just takes a shortcut right down that thing probably.
We recently fractured a well with a burst liner. We ran a packer in below the burst, and the only difference, the only separation was a swell packer. We fracked east-west with no communication to the backside of the swell. You know, it's
Yeah, that one's, well, it's like I say, we're 1 to 5 miles away from what we work with, and we make a product that we can't touch or even see, and sometimes you just have to use your imagination.
This is my third fracture.
Well, I've done a couple of hundred, and I still find things like that. Thank you very much for coming.